Thanks, Jiffy. Yep. Just hold on to this a lot easier. Cool. So hey everyone, how's everyone doing? Cool. You guys seem very excited. Got a thumbs up. That's nice. This is really good. So today we'll be, well, New Zealand DataOps, I guess. We're a meetup about 3 years old. So, you know, join us, come to our sessions. We've also got Product Tank team here too, so join their sessions too. Now, we'll be talking about the importance of strategy and data. And why didn't I write this as data strategy? Because everyone says that's the outcome, but it's about the strategy that needs to be built into the data program in order to make something successful. So we'll be talking about that. We'll be talking about experiences. We're not going to mention any client names unless we do it by mistake, but we'll talk about the challenges they face within the team and within the organization when it comes to data science, data engineering, and data platforms as a whole. Now, I'm going to skip all the intros about myself and Chetna, so we could discuss that later. Zoom link, skip through that. Now I'm going to skip through that and get straight into it. A bit about Data Engine. So Data Engine, our mission is we make data simple, accessible, valuable through modern and unique approaches to help business optimize the efficiency and gain competitive advantage by unlocking unsustainable value. Quite big, isn't it? But what we really do is we help bring this new methodology like DataOps, Datamesh, MLOps into organizations and then increase adoption and also increase value as quickly as possible. So it's a different way of doing things. That's the key focus. And that's sort of the crux of the business is we help advise and consult around the three methodologies. And the other one we focus on is playbooks and maturity models. A lot of businesses, you'll see this through the talk is, you know, everyone that jumps into data science says, hey, let's get a data scientist in there and they'll solve the world's problem, okay? But you don't have a platform, you don't have a tool, you don't have the technology, you don't even have the bloody data. So that's usually the first issue. So usually we help business realize that and build the steps to success because success only comes when you build the foundations around it. So we help with that and we also help with architecture a lot. Now, key crux of our business is we try not to sell tech, although eventually it becomes to that, you know, AWS or Azure or Google, all these clouds are great and there's tools like Pentaho, Talent, millions of them. But we try to make sure people lay those foundations before they get to that outcome, but also understand the value at the executive level. Because I think one of the issues is when you hire smart technical people, great, you know, like they do their job really, really well. They build ETL pipelines, data warehouses, and everything else. But execs don't understand, they don't even know how to actually spell out ETL. You know, what is this thing? And if you say extract, transform, and load, they'll still be like, what is still this thing? So it's really that language, you know, this will give me business value. This will actually help us understand customers. And that's where we play is that bridging between technology and the business as a whole. And we also help New Zealand. So we hosted GovHack, we do New Zealand DataOps, we're part of the Regional Business Partner Network, Business Mentors. We work with University of Auckland, Canterbury, Wellington. So we do a lot of work outside to help New Zealand as a whole. Consumer data rights, we help input into that, which is the GDPR of New Zealand that's coming to life soon. So we assist as much as we can on the way through our company. So that's enough sales pitch from us. We're going to move past the sales into why you guys are here. Now, a couple of things. So what are the facts? What is the world sort of getting to? Is I can give you simple ones. Data will double every 2 years. It bloody doubles every 2 days on your mobile phone if you take pictures every day. So this is the situation of life is it just doesn't double for organizations, it doubles for us. But other facts is the cost of bad data is around 15 to 20% for organizations, okay? Now today we will be not talking about data governance, that's another topic on its own. But if you have bad data in and bad data out, there is a cost that you're already paying in the organization, okay? Number two, data-driven companies are 23 times more likely to acquire customers. So any startups here, you should take that back and put that into your business case right now, okay? So again, another important fact, they nearly double their operating margin. So margins are getting lower and lower, especially for telcos, utilities, and larger companies. So if you want to get a 1% on $1 billion, data can help you on that journey, which is a lot of money. And the last thing is 40K more revenue per employee. So that's more US figure. So I'm assuming it will be around that or more in New Zealand. But if you do have a good organization that's data driven, you can bring in more revenue based on employee size. So why isn't people doing it? Do you guys all have a data strategy? Actually, who's got a data strategy up here? Anyone got a, okay, Julian's got one. Any other data strategies? Nope, nope, okay. Well, you guys all need one then. Now, couple of vision things. Who's been through digital transformation here? Okay, there's one, two. Okay, cool. It's exciting, isn't it? Yeah, it's cool. Okay, I think that world's moving on. It's about business transformation. And we'll talk a bit about that because digital transformation was a push exercise. You have a big, massive program, hundreds of $millions dollars, you push technology out and you transform the business. Now it's about business transformation, especially with cloud coming in, because you could buy small and then grow as part of it. And that's where the world is kind of going. And I think with this, I wanted to share my vision. And this vision has been around since 2011. I actually brought it up in Telstra when I was in the product management team. But I think the world where it's getting to is there's going to be more linked data, okay? Data is a lot more accessible and you can convert it to any format you want. Number two is where the world is getting to is more contextual experiences. Everyone wants that app to know them. They don't want this bloody thing that tells me something that is not related to me, okay? And the last one is semantic experiences. So think of semantic experiences as if you had something delightful, like you had an aha moment, wow, this is really, really cool. I didn't expect this. That is what a semantic experience is. It's something you didn't expect, but it's contextual to you by bringing different things together. And I honestly think, although I built this vision in Telstra that long ago, I still think the world has still got 20, 30 years to go until we get to semantic, but I still think that's the vision that I believe the future will head towards more and more as we connect the data up. Because at the end of the day, you need to connect the data to create that vision or link that data. Confusing vision? Nope, okay, everyone looks excited. Okay, now challenges. You can't start a strategy without problems because otherwise it's just a vision without a purpose, okay? Now, you got to remember challenges are very different. If you got kids, the challenges for your kid is very different. You know, they want to play Roblox or Minecraft. That's her challenge, my daughter's challenge right now. But my challenge is she needs to actually go study. So our challenges are very, very different. And the same thing exists in businesses, okay? So the challenge for your customers is customers are hungry. Telcos will love this. So I'm kind of looking at you, you know, they want choice. They want to change. They want to quickly shift between providers. It's like electricity providers and telcos, you can change quite quickly. Even home loans, you can change so quickly. So that's what customers want. Number two is customers want digital engagement, especially after COVID. Who wants to walk up into a bank and, you know, bank a check, I guess, nowadays? You want to online transfer, things happen through an app automatically. That's life now, isn't it? And that's what customers want, especially the generation in here, the university students. And the last thing is they want things to be done quickly. I want that answer now. I don't want to put 25 passwords before I get to the end and then authenticate 20 times. I want to just use my fingerprint and get to that experience as quickly as possible. That's where the life of customers is getting to. Now, customers are demanding, aren't they? They want the world, but no one can ever deliver that. Now, if you look at chief data and digital officers, their challenges, now just CDOs or could be heads of in organizations. It could be a manager within a business. Their challenges are, you know, projects are failing to realize value. There's a lot of projects that fail. There's between 60 to 80%. If you're in data science, it's 80% of projects fail. But in data, it's slightly less, but still, there's a lot of projects that fail. That's the challenge. Number two is traditional data teams expensive. So you guys are all expensive here right now. I don't know how we're going to solve that, but I think once you look at it from a numbers perspective, especially in New Zealand and Australia, it is really expensive to build out a data team. Okay, so how do we do it more efficiently? And I think data scientists and data engineers is the new way of tackling that, where you don't need partitions of layers of resources to get the same outcome. Traditional processes don't cater for science and engineering. So usually you hire data scientists and suddenly they don't have data and a data lake and some data processing tools. They have to use Excel. And what happens with data scientists is they get frustrated, okay? So this is the other challenges. Those processes, those methodologies are not embedded. The foundations are laid for those resources. The next business thing is businesses don't know what they want, which is quite common, I find, is, hey, I want predictive today, but then tomorrow, no, I need that revenue forecast. So it seems to be an ongoing cycle of changes, and it's quite difficult in data teams. Chief data officers' life is short-lived. Sorry, not lives, their role is short-lived, probably because it's a very, very tough role to play in organizations. Organizations don't value data. And the last one is data technology keeps changing, especially with cloud providers adding a new tool every week or every day. So that's their challenges. But then if we look at data teams, they don't really care about that stuff. They don't care about money, organizational goals. They care about the goalpost keeps moving. They have issues with siloed data. They have issues with formats. They have issues with errors. They have issues with bad data in, bad data out, so I can't produce you something that's valuable. Data pipelines, skills are not being leveraged. Hey, I'm a data scientist, why am I doing Excel? And manual process fatigue, and the trap. The trap is really, hey, I'm doing this project, but we have run out of money, so I've got to pull that project out. And you're like, what do I do now? It's, yeah, so these are the issues that, the issues are very different, but these are challenges from different angles you got to think through. Okay, and this is how a strategy thinks it through, because a strategy has to start with, I think a strategy needs to start with the customer. What's the value you're going to give to the end customer? Then work your way backwards into those challenges within the business as a whole. Now, what is strategy? And this is not data strategy, this is strategy. Strategy is a unified vision, objectives, roadmaps, a roadmap to achieve long-term goals. Fluffy, isn't it? It is meant to be fluffy. Now, really, I think the key thing here with strategy is you ask the question, why? Why are we here? What's the reason we need this strategy? Are we running out of money, or are we getting competitors are eating us up? Are we losing employees? Are we losing customers? So these are the things you need to ask. Next thing is strategy is, what do we want to achieve? Do we want to grow revenue? Do you want to grow market share? Do we want to become global giants like Google or whatever? But you need that what? And the last is how. How should we do it? Like we build a data lake that will take over the world. Please don't do that. But yeah, that's one of the, that's how is what's the solution to it at a high level. Cool. Now, a data strategy is similar, but different, okay? A data strategy is more domain centric, and this is quite important. It's basically, if you look at it, it's a unified vision. So the whole organization is one journey together. The second thing is about improving access, not for technical people only, it's improving access for the business users as a whole. So that is quite important. It's better governance of data and the teams. I kind of combine that together, but that's important again. Quality data means quality outcomes. Data-driven culture. And the last one is smarter services, which is what you want to get to. But you can't get to smarter services without sort of starting at the top of the, it should be the other way around, but snakes and ladders coming down that stairs, falling down the stairs. So that's what I believe are the key pillars of a data strategy, is you need to have those foundations laid and matured at some level before you get to those smarter, cool services that you want to deliver to your organization or to your customers. Cool. Now, it has to assist your business strategy. It's a continuous loop. Your business strategy should feed your data strategy, and then your data strategy will say, hey, we're doing really bad here. It will feed the business strategy. So it's a circle of life. Sounds like Lion King right now, but close enough. Yeah. Cool. Now, symptoms of a strategy, not COVID, please. So slightly different symptoms, but the key thing here is symptoms is siloed everything. If you guys are facing some of these challenges, these symptoms, you'll have siloed everything: siloed processes, siloed people, siloed cloud, siloed infrastructure, siloed processes, siloed securities. Yeah, we can go on and on. Okay, so if you're facing those challenges, or you're facing multiple of those symptoms, you've got a data strategy problem. If you've got fragmented operating models, you've got limited trust in data, and that's more by the business, then you've got a challenge. If you've got red tape, politics, that means you need a strategy because everyone's probably trying to build their Game of Thrones environment out of that. If IT owns and governs the data, does both, that's a worry. You need a strategy because the data is usually owned by the business. If you got technology is new, but the approach is old, you need a strategy. If you got limited value, which is quite an important one, if you're not delivering value that's making people excited, that's an issue. That's a foundational issue. If you're spinning cycles, if you're going round and round doing the same thing, hey, I just went through this, I just ingested this data last week, why am I ingesting it again? You have no strategy. And then if you got one size fits all, if you built a SQL server that does everything, you need a strategy, please, right now. Yeah. So those Frankensteins, that means you need a strategy. So that's the key symptoms of strategy. And that diagram on the right-hand side is all those issues. So if you got like spreadsheet people that run around, pull this data together and ingest it and then manipulate it, then they go back to the start again. It's like snakes and ladders. So you keep going back and forth to get the final insight. And then you got to do it again tomorrow for the next insight. You need a strategy. Okay. Sounds like symptoms in your business team? A few hits. Cool. Okay. We need like a lockdown approach for that one, I think. Now, a couple of things. The buzzwords. We're just going to demystify a few things. Who's heard of Datamesh? Okay, cool. Awesome. So the new buzzword in town, I guess I call it within the data landscape. Now, what Datamesh is a practice for centralizing and decentralizing architecture. And it focuses on product thinking as a whole, but it's not everything altogether. Now, it does rely on you separating your operate model into different parts of the business with single layered governance. We're working on Datamesh right now across Australia and New Zealand for a client. It is a complex beast, but it's powerful if done correctly, and it needs a strategy because it's not something you just do and you say you've done Datamesh. It's a 5 to 10 year journey for any business as a whole. Okay, that's Datamesh. MLOps. Actually, Chetna, do you want to do the MLOps? Yeah.
So MLOps is basically a practice with which you can get data from different sources, model it, that is basically evaluating different options. There is a process of productionizing it and then maintaining a release, that is ongoing improvement of your model.
Do you want to do DataOps too? Okay. DataOps is basically a practice of communication collaboration between different teams. It's really bringing people together on the same journey. Now, the key thing is it's about delivering value together, not in silos, which is usually what happens in organizations is you have one outcome, but everyone kind of works in layers, which is the issue. Now, we're going to demystify this a bit more as we get through it. Now, this is my cool animation. This took me time, so please, hopefully it works. Now, what's happening? The next phase in this data world, okay? Number one, all you guys have heard of cloud, I'm sure. So cloud to me is not about technology because you can get the same technology on your bloody PC if you wanted to. It's more about the consumption model, the pricing and access and all that stuff, okay? Number two is automation. There's a lot more automation, more modern platforms are coming out. And I've been in the Hadoop world, so is Chetna. But there's some way, way cool things that are coming out around this data engineering space around automation. Third thing is machine learning, the art of the possible. That's what I call machine learning, because you have to find a needle in a haystack at the end of the day, and you can differentiate and compete in market in a totally new way altogether. Okay, but there's other stuff like predictive maintenance, boring stuff, but really, really important. The other one is data management. No one really focuses on that one, I can tell you right now, but adoption and value. So data management is about quality data that will deliver value. And people forget about this. They focus on the first three, or usually the bottom one, and they forget about the top one. And then it becomes a circle of life. That's our problem now. Now, so these are the 4 pillars. Now, what's happening is we all know DevOps resources are created to help with cloud. So their job is to orchestrate pipelines, build empty platforms, I guess, that's got to be filled up. That's their job, okay? And do security on the way, and a few other things. Then data engineers came to life, and they thought data scientists will solve the world, but they said, okay, no, we've got to split this role into data science and data engineering. and this during the Hadoop phase of life. And data engineers is there to acquire data, pull it in, and then model it for purposes, but also build repeatable, scalable solutions at the same time. Then data scientists, the art of the possible. So their job is to find that needle in the mad scientist, I guess, within the data place. Sorry, guys, I didn't call you guys the mad scientists, but yeah, close enough. And then you got data architecture and really data governance or data analysts, governance analysts. Their focus is to make sure the quality of data is in the right shape and it's modeled correctly and consistently across complex organizations as a whole. Okay, cool. Now, why am I telling this story? So the reason I'm telling you is, bottom one's DevOps. If you look at the middle one, data engineering is really data ops. That's where it fits in. It's really a practice more for data engineering based organizations. Okay. And MLOps is, again, and Chetna's going to demystify this a lot more, is more for data scientists. So if you're building data science in the data science landscape, that's where MLOps fits. And Datamesh is really the data architecture and governance. It's really strategy as a whole. Cool. Now, one more thing is that girl on the left-hand side that's saying, I'm technical. One of the other things that's happening is all these people coming out of university that are heading into organizations, plus the older folks like me, the old farts, we're all quite technical now. So it's not like everyone needs to be a rocket scientist to know technology. We're all technically literate. So that's the big shift that's occurring, is they know how to use Power BI, no longer Excel, when they get into organizations. So you have to be careful here, where you need to make sure that you take them on a journey, because they might be more technical than you are in some instances. Now, where does all this fit? Strategy, ideation and design. That's where Datamesh really fits. Okay. So it's really about the strategy and the architecture of a business. Strategy word is quite important here. It's a huge change. It's a massive change for organizations. Centralized is always an option. You could always use centralized. You don't need to go Datamesh. It's not going to save the world. You got to figure out if it's the right solution for you. Okay. Then the engine is DataOps and MLOps. Okay. These are engines to build value through those pipelines from strategy to execution. So this was my very horrible way of depicting it, but I think this is where they fit. So don't try to, you can always use Datamesh with DataOps and MLOps. You can mix all three together, but you don't need to you can go centralized DataOps and MLOps. You can mix and match. But it's not one size fits all at the end of the day. Cool. Oh, and don't forget data management. Bad quality data means bad quality, unhappy people, actually. It's probably the simple way to say it. Now, when to use it, what model? Datamesh is really, really good if you got complex business models, okay? And what I mean that is you've got multiple customers, you're engaging customers in different ways, your business is fairly siloed from a revenue perspective, and there's no commonalities across it, okay? That's where Datamesh makes sense. Number two is if you've got 20 people, please don't go Datamesh. Your data team will be bigger than the organization, so don't go down that track, because you need to hire separate teams altogether. Large organizations with fragmentation, that's when Datamesh makes sense, okay? Compliance separation. If you got one part of the business that's very compliance centric and it's holding down the rest of the business, Datamesh probably makes sense for you. Split out that compliance, isolate it, and then tackle it independently while let the business grow and run on its own way, which will be in banks and telcos and other places. So this is where Datamesh makes sense. Now, DataOps really requires automation. You need automation, automation, automation. Smaller teams with agile delivery. Don't build a DataOps team or probably MLOps team with 20 people. It probably will fail. Probably even 10 plus will be quite hard. So smaller teams. Better feedback loop with your sponsors, really important. Practice-centric and data engineering, BI, and analytics. Okay. MLOps requires automation. So MLOps is very, very similar to it, but machine learning models iteration, as Chetna will kind of work through. Now, let me quickly get through the next slide. This is a cool, funky diagram to show how all of them merge together, and that MLOps is kind of data science, data engineering, and DevOps together. Pretty cool, isn't it? So the middle is where everything, rubber hits the road. So now, I'm going to get through my DataOps and I'm going to head to Chetna very, very quickly. DataOps, Agile, DevOps, TQM, and Lean. So it's really all four practices coming together to work in harmony. Okay. How many means the team needs to make it work together somehow, but that's what the practice is about. So it's really about using those agile delivery methodology, using some of DevOps CI/CD practices, which is quite important with Azure Data Factory and, with Glue and all of these things. You need to sort of do the CI/CD patterns. You need that continuous monitoring and testing. So you want to automate all that as much as possible. And the last one is lean. So it's really identify where there's waste and focus on customer or focus on value. So don't try to make your pipelines 100% perfect. Try to sort of get it out and see if it's the right pipeline before you sort of commit to it. And really at a high level, traditional is more that top waterfall approach, which is okay. It works for certain projects, especially finance projects. You don't want to be off by $1 million for your CFO. So maybe you want to follow waterfall. But for the other projects, you should probably focus on agile. And that's what DataOps is. It's that continuous loop back to the business. That loop is not within the data team. It's the loop within the data team to the business, please. Yeah, so you've got to make sure you're delivering value on the way. Very quickly, speed 1 and speed 2, I call it. That's not the movie. So speed 1 is your innovation pipeline. So really get something quick and dirty to see if there's value. You've got the data sets and validate it. And speed 2 is your production pipeline that will probably cost you 10 times more. But that means you at least tested there's a need in the business before you build this massive pipeline that's going to cost you tons of money. Okay, so it's really about breaking it into 2 things before tackling it. And Datamesh, still a while to go. Sorry, Chetna. Okay, Datamesh. There's 4 principles. So it's Zama Dagani. I think I've pronounced it correctly. So what her principles are: domain-oriented data ownership and architecture, which means that domain modeling or data modeling kind of hits is a domain-centric. You have data architects embedded into those domains. You might have 10 domains or 20 domains in a business. Data as a product, which is a lot of stuff within DataOps. There's a bit of overlap there. Self-service data platforms, you kind of release the control of those platforms to the business as a whole. And federated computational governance, it's a mouthful, but just bloody govern the data on the way and also govern the environment. So log, analytics, audit logging, all that stuff needs to be managed. That's what Datamesh is as a whole. But the fundamentals of Datamesh is 2 things. You have a separate team. Every domain has its own data engineering, data science team, potentially DevOps, and they will have their own platforms. They might have their own data warehouse. There might be a data warehouse for the platform. So instead of you trying to build one big data warehouse, which is what the traditional way is, you might have small pockets of smaller data warehouses and data lakes. Cool. And there are challenges. I just wanted to be careful because this data mesh word is being used a lot. And I think there are so many challenges with it. And it's I just want to highlight that, but there's also so many advantages to it. The challenge is it's fairly new and tested. So just be careful on how you implement it. Think it through properly. Number 2, cloud isn't fully ready. I've picked up that on Azure and AWS, there are design patterns for it, but it's still not there yet. It doesn't cover the 4 pillars fully. It's more just the architecture component. The other thing is it requires high maturity and investment. If you read all the blogs, all of them say you need 5 to 10 years of investment to make Datamesh successful. So it's not about a technology play at all. Datamesh is about a people process play with technology. Technology is the last thing on the way. Leads to fragmentation, but cost of speed. So speed is probably more important. If your business values value from your data, then who cares about the cost at the end of the day? Requires a different operate model. Cross-domain analytics is a gap. So if you got corporate data, who owns the corporate data? Is it finance? Is it marketing? Or is it this business unit here? Or is it this business unit? So that becomes a debate. Who does it? So that's a gap you need to think through. And the last one, it's a high cost to serve, but you have it's a high cost to build and operate because of the teams that are separated. I think cloud cost is minimal. I think it's the hiring a data engineer, data scientist, and a data manager, all these roles will probably cost you $500,000. So just be prepared for each team being a cost on its own. But there might be so much value you get out of it. So just these are little challenges. I just wanted to demystify with Datamesh because everyone's talking about it, everyone wants to do it, but you just need to be careful. You've got to figure out if it's the right solution for you. Cool. Over to you.
Thanks, Akash. So the next is what is MLOps? So MLOps is a practice of delivering machine learning value over using agile ways. and do it with the feedback loop. So it's basically composed of 4 main factors, that is data, ML, dev, and ops. We'll go through each of that, and it's a loop. So the way it goes is it first does data, ML, dev, ops, and from operations, it takes the feedback back into data, or it could just take it back into ML. So the first loop, there is the data that is purely focused on how you bring data and what data is needed for your data science ML model. In that phase, what we start with is first understand what are the requirements of your machine learning model or data science problem. It moves into what are the data sources available. Are they available in your data lake, or you have to point it to your direct sources or different databases? You start exploring data, get a feel of data. What are the columns? What are the different attributes which are there in the data? And that way you come up with the features which are like critical for your problem. So think like if you are doing a customer segmentation, then you start with what are the different attributes of customer which makes a good fit for your segmentation model. Once you figure out on that, it jumps into the next loop, that is of the machine learning. So this is purely focused on, you start with evaluating different algorithms on that features, which gives you a better performance. Like again, with the segmentation, what are those different factors which is giving you a better segment of a customer? That's what the model evaluation phase is there. And to get that, you need to come up with those different, once you get with the algorithm, you have to do a tuning of those parameters, like what is working for you? Is it the 0.1 value of that factor, or is it the 0.5 value, which gives you the best performance? You keep on training your model with different kind of parameters and different kind of data sets. There will be a static data set, which you already have in a data lake when you build the model. As long as you will train it with the stream of data, which is continuously floating. For example of customer segmentation again, the customers are doing their transactions on regular basis. You have to train your model with that upcoming data to evaluate how better it is performing. Once you come up with that, it hops into that dev phase. So dev phase is basically a normal development cycle where you test how your model is working. You document what are the critical things about model, your model, how it's configured, or how it's working, like what algorithm you used, what you evaluated, all that stuff. You package it nicely. So if you are using external libraries or something, you have to package it. You can build different jars so that it's easy to manage and it goes as a complete solution in production. And once you agree on that, you plan a deployment to a production. So that is the development loop. And after development is done and you agree with the planned date, it goes into the operations loop. So operation loops is nothing but it's focused on how you deploy your model into production and how you maintain it on going forward. So what you start there with is you first configure your parameters for the production. You release that model into production. And then you start monitoring it, how it's working. So monitoring comes into 2 factors. One is you monitor just the infrastructure wise, whether you have enough resources and your job is running or not. And the second one is you monitor the performance of your model itself, how much accurate results that model is giving over time. To do that, you have to do ongoing support of that model as well. Like if something breaks, you have to fix it. You have to take ongoing feedback from your business users. Sometimes we call it bad feedback, because often the actual model is evaluated in production because it's giving you output on real-time data sets. So you take that feedback and you, if there is some major changes, like you notice that, oh, if we use X attribute out of customer, it could improve the performance. It hops again into that second hop, that is the model section. You start adding that attribute, again evaluate it. So basically, if you look at MLOps, it's you're delivering your machine learning's value with small hops rather than just spending a lot of time on your machine learning model to be developed, tested, productionized. So it's going into hop by hop basis. So yeah, that's what the MLOps is. Now we know we learned about what is MLOps, what is DataOps, what is data strategy. Then the questions comes, okay, so I got my strategy, I got all these methodologies, practices. How should I structure my team to deliver that strategy and value? So there are 4 different models with which you can structure your team. The one is the centralized one. So in this model, basically what you do is you come up with a team, you stood up a team of different data engineers, data analysts, and data scientists who are centralized in one team. And they work with different domains. So in this diagram, if you look at supply chain, finance, HR, all these are different domains. The way interaction works in this is your domain business users, they request their needs to the central team. Central team, depending on their resourcing and skill set, they deliver the value back to the domain. So if you notice with this model, what are some challenges which you can notice with this? The one is because it's a centralized team, it's often resource bottleneck. So it's good at delivering a centralized value like common practices. It can give you standard patterns, but it's often lacks that ground knowledge of different domains on like how things happen within that domain. That usually then staggers the overall process of delivering value. It's good if you have just one particular domain or one particular business area and you have to focus on that. But if you have a different business needs from each domain, then the centralized model work for some time, and then you will start noticing that different domains are starting to hire data scientists or data analysts to fulfill their needs because you can't get the resources from central team. So the second model is often where companies start is like without having a central team, their existing analysts like pricing analyst or commercial analyst, they start doing that reporting, ongoing reporting of their existing data sets. And that's how this model works. So one of the analysts or one of the existing person from finance could take up the role of doing analysis of all the finance assets. They do the financial reporting. Similar thing, it works with the sales and marketing department. One data scientist in supply chain could start doing some prediction of like what the inventory needs would be over time. So what are the challenges do you think of this model? So one challenge with this model is because it's fragmented model, there is not constant practices. Supply chain could be using Power BI, HR could be using Crystal objects, and sales could start using Excel for reporting. So that's what it end up. Another is with the tooling, they are not consistent, as well as the practices wise or business rules wise, it's not consistent. So example of how you cleanse your customer data. Supply chain could do it with capitalized customer name. Sales could just do lowercase customer name. So they are not consistent practices on engineering as well. So that's one challenge. But the thing which works with this model is it delivers value quickly because you have resources within your domain. So if you have to build a report, you can just go to your domains analyst and ask, can you build this report? And you have a report. The third model is the functional model. In this one, often this is called as a siloed operating model. So you create a silos of data scientists, reporting analysts, and data engineers who are there to fulfill your engineering and different data science needs. With this model, there's a lot of communication happening between different domains and a centralized team. Often this leads to conflicting priorities that one domain will say, oh, my project takes high priority over marketing. Marketing could say, no, I want my marketing model to be delivered before supply chains initiative. So what you have to do is then you have to keep fulfilling those roles within your central team. And the best thing about this is you get consistent practices. So you are following a consistent practice for each of your domain. The only thing is the prioritization becomes a bit difficult. So how can you solve all these challenges. So there is a fourth model, which is center of excellence, often known as hub and spoke model. So in this model, you come up with a team, which is a centralized team of data and analytics, who acts as a foundational team, who set up all the infrastructure, who gives you those best practices guidance, who gives you those templates for setting up your data infrastructure, data pipelines, your data science models. They can tell you like how you should do a data model development. They can train you on how you should write a data pipeline. And then you have a bunch of different data analysts and data scientists hired within domains who are there to deliver that particular domain's value. So a good example of this will be, let's say if we have to do a financial forecast. What financial forecasting model could do is they use the data which is centralized by data and analytics team in a platform. They follow the practices which are developed by a central team for CI/CD and model. And the only crux which they have to do is what's the main thing which goes into that, how the forecasting works, the main business knowledge that is worked on that. The pros of this model is business gets value in a quick ways with a consistent approach. So it starts delivering that value, and it works very well with Datamesh kind of model where you have your domains and you still have a central of governance. Yeah, I will pass it to Akash.
Cool. Thank you, Chetna. So this slide, I'm not going to spend too long on, but I guess the key thing is the steps to success is it's really steps in some parts on this diagram, but you've got to figure out where you are in the maturity journey as a business. You can start innovating in some of that cool stuff and create and manage, but if you want to deliver it across the whole business, you need to make sure you lay the foundations. So it's quite important that you have a maturity model in your business and you use it to ask for money or ask for more resources, because you've got to lay those foundations at the start. I'm not going to spend too much time. I'm not going to go through each one of those things, but I'll send the pack out later so you can actually understand it more. Data strategy also has pillars. It's really important that it's not a journey of one person. It's a journey of the whole business to become data driven. And those pillars are strategy, program, architecture, governance, and knowledge. And knowledge is probably quite important because you've got to share those use cases. You've got to share those insights back out as much as possible. This is just a typical structure. There's more complex versions, but yeah, this kind of gives you those layers and we could sort of start at a different angle. Now, key callouts. Now, we're sort of getting towards the end of it. And I guess there are pitfalls, but there's also so many pros and cons, pros to having a data strategy. I guess a couple of callouts: have a strategy, get buy-in. And I'm not saying get buy-in just from the team. It's important your team's on the journey, but get buy-in from the execs all the way down. It will help you move faster and quicker, especially with funding and governance. Okay. Number two, don't mature too fast. You'll fail. Like if you don't have a data lake established, don't go do master data management and all these things without some foundations laid as part of it. So just try to break things up and make sure there's a sequence to it. Don't forget about enabling access to the business. I think a lot of people think that although we're building the platform, the data is theirs. It's not IT that usually owns the data. Most organizations, data is owned by the business. So you've got to open up access to them. It's about use cases and always align to business goals. Pretty simple. Start with the simple use cases. Don't do big bang. Break functional skill sets out. I think one of the issues I see is where you get one person that wants to be that ninja that does everything. And that ninja usually becomes the problem or the issue in that organization. And you just need to figure out how do you break that down? And that's not the ninja's fault. It's the organization that created that ninja. You've got to figure out how to break that data engineer resource out from the data scientist, from the reporting analyst, so you can get something to scale out wider. Also get a PO on board. Product owners help, product managers and product owners, just to sort of let the team build things while focus on building or developing versus the politics, that although POs don't do politics all the time, but they help with that. Use tools to solve some of the issues. Cloud is so cheap, you can get started with cloud. But yeah, people are way more expensive in New Zealand and Australia. So just look at tools to automate things on the way. Use methodology, and I'm saying try, because it's really important you test it and see if it works, if it's the one size fits all. Remember, a methodology is not something, it's 100%, you must follow it 100%. You try bits and pieces and see what works, and you pull things out that don't work, or if you're not ready for. So that's quite important with methodology. And learn and measure your failures and success. That's the most important one, is a lot of people forget to say, this didn't work, and they go back into that cycle of repeating those failures. Or if you've done something really, really cool, go out and talk to the world, go talk to the business about how successful it's been, or even within your team. So celebrate the success. It's really, really important. Now, my sort of last, those sports movie slides where, last minute thing, oh, you can't do it, you can do it. So I'm not a Denzel Washington, so I won't try to be him, but push the boundaries, really, really important. You have to push the business, and the business will push you harder. Be prepared for that. That's going to happen, because they usually catch up faster than you can catch up with technology. Unify, partner with the business to make it successful. Don't do it alone. It's going to fall very quickly. Challenge your team members to do it differently. Challenge the architecture team to do it differently. Challenge everyone to think differently. I think it's really, really important. Think about the future. A lot of people think about, hey, I built this pipeline on Excel. Great, cool, but how can you do it better? So think about future. What can I do to make this more successful and more repeatable? Teamwork, really, really important. It's not about the data engineer being a role and a data scientist being a role. It's about you as a team working together to make something successful. That's what a lot of people forget about. It's not about individuals. It's about the team working together to make something successful. And celebrate the successes, which is really, really important. I think some of the stuff is actually in sports sort of rules of engagement, but close enough. Yeah. That's it. And the last thing is data is the gravity that's holding your business together. Are you kind of stuck in one place? And if it's the case, then you need to have a strategy. You need to start figuring out how you can move it faster. If you also got not COVID symptoms, but those data strategy symptoms, that's another reason why you need a strategy. Now, with that, I'm going to stop. So thank you for the session, and thank you, Yiffy, for hosting us. Really, really awesome. Data Engine, it's just a quick one. We're hiring resources, data consultants, data engineers, and data governance analysts. So if you want, reach out to myself on LinkedIn or just connect with me afterwards. Always looking for good talent in his own. Now, with that, I will hand it to Yiffy.
I'll just do last words, and also I'm sure we'll have some questions from the crowd for you. Yeah. Before we get into that, though, we've also got Anthony, who is also advertising for some data engineer roles for his company Harmony, right?
Yes, so we're the company Harmony. For a lead. Yes, sorry, to speak into that. So I work for a company called Harmony. We're looking for a lead data engineer to drive our data practice. We've got a whole lot of really interesting transformational stuff going on internally at the moment. So it's a really amazing opportunity for someone to kind of take a hold of our data practice and drive it. And the one thing I'll also say is that we're also one of the few companies who actually have real live machine learning models in production doing really valuable things. Something I'd advise everyone is if you're talking to companies who say that they do machine learning, ask them whether or not their machine learning is actually live in production or whether it's just in the lab. So is it just part of that? Akash talked about speed 1 and speed 2. Is it just speed 1? Because speed 2 is actually quite hard, but having it in production is where the value is. We have it in production, so come join us if you can.
And with that, we'll just move into the Q&A section of the talk. So for the people who are actually attending online, instead of flicking through all your comments on Zoom, we'll be relying on a Q&A service called Slido. But if you're attending from today, if you're attending from the lecture room today, I think, Akash, you're happy to just answer questions that people can yell out to you. Sweet. So any questions from the lecture theater?
I have a couple of questions. One is Datamesh. I worked as Westpac for a period of time, and Datamesh was a big thing there. And it's quite new, as you mentioned. Also, we have found that AWS, for example, and Confluence, they have their own view of what Datamesh should be from an architectural perspective, maybe.
That's a challenge.
So you have put so much emphasis on it. I would like to ask, are you in the journey of implementing one that you think is in the right track? Or have you seen one that has actually provided a lot of good value as you promised?
So good question. So with Datamesh, we're on a journey with a large client in Australia and New Zealand implementing this, probably one of the biggest in Australia. And it's a journey because it's going to take 3 to 4 years to implement. And whether it's been going to deliver value will be probably in about a year's time, we'll figure that out. But I think what I'm picking up right now is if you've got an organization where there's a hunger for data and it's locked away, then the value will be realized really quickly. So we're already seeing some of our clients with some amazing data science use cases because we unleash the data into their own platform where they can run and build their own things. So we're already seeing that. Nothing's in production yet, but we're seeing this innovation occur very quickly. Yeah, and I totally agree. So one of the issues with Datamesh is like Azure's got its point of view, AWS has got its own point of view. There's another 25 people in the world that's got a point of view. There's no real concrete like strategy around it. So I think that's the key thing is got to be careful. Yeah, and see if it works for you.
Maybe for later, to follow a specific view of multiple data, and people around will have their own perspective on what should.
I think it's own perspective because the key thing is you've got to sit down with the client and understand the pain points and the problems, then derive that. So there's no real specific point of view. It's just understanding where the business is, how complex is their business model, compliance, their strategy, their issues, and then deriving the right view. That's my personal thoughts. Don't do one size fits all. It just doesn't work. Yeah. Awesome.
Yes, interesting. How you did your domain separation, the Datamesh.
So for domain separation, we did it by business models, by customers. So if they're servicing a different customer and domains, then we split them up. The domain separation is at that layer for modeling perspective and from a team perspective, then it's a platform. Datamesh per se is meant to be an isolated platform and network infrastructure for that line of business. So we separated out everything and rebuilt it. So every line of business has their own data lake, data platform, ETL, everything wrapped around it, like packaged up. And you got the way to think about Datamesh is like city council. Well, New Zealand's gone the other way. We've gone back into one council, but most places in the world, they have a city council, then they have smaller city councils. That's what Datamesh is. You're just kind of releasing it out, but the bigger council still controls it at a governance level, not at the policy level. And that's what we're doing is we're building these little platforms, isolated platforms and governance models around it. Hopefully I answered your question. Cool.
Hi, I've got a question. I'll just be representing the online questions. So I've got a question here that says, they're interested to know how knowledge sharing among SMEs work. So data engineers, data analysts, data scientists, and also data consumers. For example, have you used or come across any tool recommendations for data profiling, either open source or commercial?
Okay, I can take that one. So for the knowledge sharing, there are multiple ways which companies use. So they can, they have a community of engineers, kind of sessions where data scientists, data analysts, and data engineers, they come together to share what they have built, what are the common patterns which they have developed. That's one way of doing it. Another way of doing the knowledge sharing is some companies, they even have a knowledge hub kind of portal where they start documenting all these practices on, like, say, how to do a pipeline on Databricks. They can put steps on that, and they can make it more generalized so that anyone can pick that up and have a consistent pattern. For profiling, for data profiling, there are a couple of tools available as free, like open source tools like Great Expectations or DataDQ, with which you can actually configure different quality rules and measure how your data is working on those different DQ attributes like accuracy, completeness, and its consistency. And you can then monitor it over time. What I have also seen about profiling is people start doing metric dashboard of these DQ scores. They call it DQ score or metrics. And then they start tracking it over time. Like, what was my score of customer data set in April 2022, how it's working in May 2022. And that's how you can build it up.
Do we have any more questions in the lecture theater, or should I go with the online questions? Okay. Oh, sorry. Hold on. Before you start, we just have a few comments from online saying they can't hear the question. So I'll just pass you the mic so that the online stream can hear us as well.
I will try to summarize and make it not a long question, but I used to be leading a teams of engineers and data scientists a few years ago, and we adopted a practice that in the US was called full stack data science that follow the diagram you showed quite a lot, giving data scientists a lot of tools for them to go from ideation all the way to production. It wasn't for free. We need a lot of time and effort to do it. But I noticed in the diagram that there could be a split on the testing phase where you have data science and then dev. And talking to friends and colleagues, that seems to be a concern in many companies where data scientists create a model, then that engineers cannot necessarily understand it easily. And they end up either copying and pasting what data scientists did and put in production, which will have a lot of issues then later on. Or they try to refactor it to make it more production ready, but then it might not follow the model effectively. So do you have any suggestions there, or have you used this full stack data science approach or any other model you can, or is my assumption true that middle test layer could imply a handover and therefore some knowledge is lost in that translation?
So
Just the microphone.
I could say is instead of isolating the boundaries between who does the model and who productionize it, you can tackle it in two ways. One way is if you upskill your data scientists who are building that model with the new tooling, they can make it production ready. Or ask your data scientists to focus more on algorithm and then provide them with those generalized templates which they can use to make it. So take an example of model. So you could parameterize your model with like what data set you want to read. You could write that chunk of code, that development team can write that chunk of code to read your data. You can pass features names as parameters to that. And then you can just tell them like, these are the 6 algorithms which I want to evaluate with these different parameters. And that code can do that and give you the score back. That's one way of doing. I can relate to the problem which you said, like data scientists often prefer, that was quite old, I'm not sure now, but data scientists often prefer to develop their models on MATLAB kind of tool. And the production developers, they prefer to deploy it with some advanced tooling like MLflow or something. That's where the boundaries comes into picture, like how you translate your MATLAB into MLflow. So I think in that case, the production engineers should provide them with more parameterized code, which data scientists can easily use and deploy it.
Should I pop out a few more questions from the online stream? So I think So someone asked, how can Datamesh get a full view of all the data if there are siloed data warehouses everywhere?
Could you ask the question maybe 3 years from now? Then I could, no, just joking. It's a tough one because you are fragmenting the data. So how do you get a full view? You need to look at some kind of data governance, profiling, scanning tool to get that full view. You'll need to look at it from a metadata layer versus a single storage layer. Yeah, and that's probably the biggest gap on cloud right now is their capability. So you might need to build something custom to do that governance, centralized governance across your data sets.
Cool. I hope that answers the question of our online viewer. And also we have another one here that says, how would you deal with senior management who just say MLOps is too slow? I need a model quickly to see value.
Tell them you need more money. Yeah, I don't know. What do you want to have?
I think, that's the way it really depends on how your senior management see MLOps. If you are truly agile way of MLOps, then it's not slow. But if you are doing in a traditional way and still calling it a MLOps, then there is a problem.
You're right. I think like Chetna's highlighted one thing is sometimes you brand something, but it's actually not doing that. So like you could have a Tesla, but it's really just a Toyota underneath. So you just got to be careful when you use those words because you set expectations with executives. But then also executives need to understand that machine learning is not something you turn on. You got to actually nurture it and evolve it. And it's got so many challenges. If they don't understand that, they probably need an education session around it. Yeah.
We've got another question that came in. Do you think it's a good strategy to start with initiating data lake and then slowly building through Datamesh sourced from multiple data lakes?
Yeah, that's my recommendation right now is I've got different names for it, but you would start from a centralized data lake and then you'll float it out to different little lakes, I would call them. I was going to call them puddles, but they would be bigger than puddles. But yeah, that would be a strategy that you can evolve and test and then come back. It allows you to always fall back, that strategy. While if you went full decentralized everything, man, that's going to be tough because you're decentralizing all your IT teams, you're decentralizing all your platforms. And that's a long journey. That's a tough strategy to tackle as a whole. It's not a technology challenge, that's a business process, organizational strategy you got to tackle there.
Great, thank you. Any more questions from the lecture theater? Or I might just finish off with maybe one more question from online. Because we do have some pizzas outside for the catering for this event, and they are getting cold. Okay, I don't think I see any more questions from the lecture theater, so I'll top it off with one final question from the online stream. Will data fabric products solve issues with siloed / non-confirmed data warehouse or data lakes? Or is that just going to add more complexity?
Do you want to have a go at that one? I find we don't do much with data fabric, so I'm probably not speaking with the right experience on that. But it's similar to Datamesh in a centralized approach. That's the way I kind of think about it. I don't know, like it's a tough one. I think you got to figure out what Datamesh, data fabric, DataOps, MLOps, whether that fits and whether it's the right for your organization. But I think the key thing with Datamesh, it's an organizational strategy change. And that is the fundamentals. It's not a technology play. While data fabric, you can start with technology and then drive it into organizational change. But with data mesh, if you don't start at the organizational change, you're going to fail very quickly. Or you're just calling it data mesh for the sake of data mesh. Yeah. Hopefully I answered that question properly. Yeah.
Cool. Thank you, Akash. I think with that, we'll start wrapping up the event. Yeah, thank you again, Akash and Chetna, for coming to present with us at the Data Science Club. And our PR executive, William here, has prepared a little gift for you guys as a token of appreciation for giving up your time to talk about Datamesh, MLOps, and DataOps today. So there. Yeah. Sweet. And yeah, like I said, there'll be some pizzas outside for free flow questions and networking. Like Akash and Anthony said, there's opportunities for employment as well. So yeah, from this point onwards, I think we'll be concluding the event. And for everyone attending online, thank you as well for sending through your questions on Slido. Yeah, that marks the end of data science physical events for the first semester. And we're continuing after the semester break with events from ANZ and AWS, as well as Loyalty NZ. So they'll be coming in to talk about the interesting things they're doing with data science in their companies. So if you're interested to hear more with those companies, I urge you to sign up to our club with uoadsc.com. And that's when you'll get our newsletters and know about our upcoming events. Yeah.